Who's ready to learn some properties of logarithms? Are you ready? All right. So the first property of logarithms is the product property, meaning you're multiplying and they have the same base down here. So if you look at the right side of this first. If you have log sub b m plus log sub b n, they're both log sub b. So you can take the m and the n and you can multiply them. So when there's addition between them, it matches up with multiplication. So if you look at the example here on A, log sub 6 4 plus log sub 6 9, you can mush those together. We call it condensing a logarithm. And you can multiply. 4 times 9 is 36. So we have log 6 36. Now we can simplify that. You could set up an equation if you want, or just remember essentially what we're doing with the equation is we're saying 6 to the what power would give us 36, which is 2. So this will just simplify to 2. But let's set up the equation just to make sure we can do stuff like that. So remember, you'd say 6 to the x equals 36. And you can rewrite 36 as 6 to the second power, which would give us x equals 2. Now we put that x into the equation. So the original equation didn't have an x in it. So we're not actually solving like x equals something. It just simplifies out to just 2. Right? So in your final answer, don't write x equals 2, just write 2. Because log sub 6 36 is just 2. Right? So here, again, we have the same little base there, the 5. So we can multiply these together. And 5 times 62.5 is 3,125, if I'm remembering correctly. Let me double check that. 50 times 62.5, 3125. Great. So again, this is just going to work out to be one number. It's not going to say x equals something, even though we're going to set up an equation with x. Say 5 to the x power equals 3,125. So if we were to rewrite that, let's see. 5 to the third is 125. So times 5. 5 to the fourth is 625. Times 5, 3125. So that is 5 to the fifth power, which again, our equation would say x equals 5, but all we're doing is simplifying log sub 5, 3125. So it's just going to come out to just the number. You don't need to say x equals, it's just 5. Next, we're going to do division. Now, if addition goes with multiplication, what would you assume goes with division? Yeah, subtraction. So if you see subtraction between the two logarithms and they have the same base, you're going to divide the big boy numbers. So here we have log sub 5 100 minus log sub 5 4. So we're going to do 100 divided by 4. And 100 divided by 4 is 25. Now we're looking for just a number here, not x equals. So again, we can do this particular problem in our head. 5 to the what power would give you 25? 2. Right? 5 squared. That's it. So you can set up the equation, you can break it down, but something that you can do simple like this, if it's just something squared, just write 2. Okay? So again, here we're going to divide them. They both have the same base, but it's not written. And what is the invisible base then if it's not written? Oh my goodness, of course it's 10. So we're going to be doing 5.4 divided by 0.054. 0.54, and we get 100. So this would just say log 100. Remember, there's an invisible 10 down there. So 10 to the what power would give us 100. It's 10 squared, 10 to the second. That's it. There we go. There we go. Oh, the power property. Okay. This one's kind of fun. It's almost unneeded, but it does come in handy later. So if we were to set this up with an equation like ones we've previously done, we could say 2 to the x power equals 32 to the 6th power. Now we can rewrite 32, that's 2 to the 5th power. And then if we remember our old properties of exponents, when you go power to a power, you multiply those exponents. So we'd have 2 to the x equals 2 to the 30th, which then we can ignore our bases and we just have x equals 30. But again, we're just simplifying it, so we just want the 30. And that's the correct answer. That's one way to get there. But the exponent property says that when you have an exponent on your big boy number, you can kick that exponent to the front and multiply it. So this is like the same as 6 times log sub 2, 32. Now remember, log sub 2, 32 means 2 to the what power would give you 32? And that's 2 to the 5th power. So this part just simplifies to regular 5. Log sub 2, 32 is just 5. But we also have this times 6 on the outside, and 6 times 5 would give you 30. Same answer. Both ways work. But let's try it with the property today. If you have an exponent on the big boy number, bring it out in front as multiplication. So here, log sub 7, 49 to the 3rd, we're going to rewrite that as 3 times log sub 7, 49. Log sub 7, 49. 7 to the what power gives you 49? 2. Right? So all this log stuff works out to just simplify to 2. We also have to multiply it by the 3 out there, and 2 times 3 would give us 6. So all of that simplifies to 6. Now if you wanted to try it our first way there, you could say 7 to the x power equals 49 to the 3rd, and then you could rewrite 49 with a base of 7, that's 7 to the 2nd. And here you multiply 7 to the x equals 7 to the 6th, and then you get 6 that way. It works. It's great. I'm cool either way. That sounded arrogant. Oh my gosh. But, I mean, I am pretty cool. So, oh, the inverse property. So, this is a goofy one. If you look at B, because example A doesn't seem to match up with this property, so I'm a little thrown. If you have 5, and then it's raised to the power of log sub 5, 10. Now, you see how it has the 5 and log 5? Those are inverses, so they just cancel each other out. So you're just left with 10. It's kind of a weird property, right? So if we were to write our own example, because again, example A doesn't match up with this. If I had 71, and that was raised to the power of log 71, 513, right? This is, of course, we're going ridiculous on this. But you have 71 raised to the power of log sub 71. Those just cancel each other out, so you're just left with 513. That's it. That's the idea of that property. If you have something and the exponent is log of that exact same thing, those two things cancel each other out. So again, here, this doesn't match up with that. So this is saying like 3 to the something power gives us 81, and that's 3 to the 4th power. So this would just simplify to 4. So that one made it in here by mistake. All right, so let's use these properties to expand logarithms and simplify it if we can. So we have to remember all of our different properties here. So if you look here, we have multiplication. It's 7 times x to the 3rd. So multiplication was the one where it was the same base, but it became addition, separated. Because earlier we were condensing, we were making it smaller. So now we're going to expand it out. So we can rewrite this as log sub 2, 7 plus log sub 2 x to the 3rd. And then do you remember which operation went with division? Yeah, that was subtraction. So we'll say minus log sub 2y. Now, you should always check if you can simplify it apart. 2 to the whatever power can't give you 7. 2 to the whatever power can't give you x to the third. 2 to the whatever power cannot give you y. So we can't simplify any of them into like regular numbers. But I'm actually going to do one more step here. We can't leave this exponent there. So remember, when your big boy number has an exponent, we fix that by kicking it to the front. So we're going to make this plus 3 log sub 2 of x. Anytime you have an exponent, move it to the front of the logarithm. So that log sub 2 7 plus 3 log sub 2x minus log sub 2y. We're stretching these out a little bit. So here we have log sub 5, 2x to the 6th. Now the 2 is being multiplied with the x to the 6th, so that would go with addition. So we can say log sub 5, 2 plus log sub 5 x to the 6th. Anything else we need to do here? Of course, because why would I ask if there wasn't? We have the exponent on the x. We're going to kick it to the front. So log sub 5, 2 plus 6 log sub 5x. Awesome. Awesome. So that's expanding it. Now we're going to practice condensing it down. Okay, which is what we were doing earlier. Now these all have the same bases, so we're able to just start mushing them together. Now here, I see it's being added, so, well, actually before we do that, I see this 2 log 2. I'm going to take that 2 and I'm going to rewrite it as the exponent on the 2. So I'm going to rewrite this as log 2 to the second. So let me bring down the rest of my stuff here. All right, so we're going to be able to condense all this stuff together. So here we have addition, which means that when we condense it together, we're going to be multiplying. So that's 6 times 2 squared. And then here we have subtraction, which means when we condense it, it's going to be divided. So we just have to simplify this stuff. So 6 times 2 squared. 2 squared is 4. 6 times 4 is 24. And 24 over 3 would be 8. So we just have log 8. Now, what's the base there? That's base 10, right? It's invisible. It's not there. So you can't say 10 to the something power equals 8. It's not going to work for us. All right, let's try that again. So we're going to kick this 2 as the exponent here. So we'll say log sub 3 7 squared minus, same thing here. We'll say log sub 3 x to the 5th. Now here we have subtraction. Remember subtraction, when we condense it, goes with division. So I'm going to change 7 squared to 49. So log sub 3, 49 divided by x to the 5th. There we go. There we go. Now, just like this one, we said 10 to the something power isn't going to give you 8. There is a way that we can always simplify those, and it's called the change of base formula. So you can change the bases to whatever you want, and then divide them. We're always going to use base 10. So, like here, you can't say 32 to the something power gives you 8, because already 32 is larger than 8, so it seems weird. So what you can do is you can rewrite it with a base of 10 and then divide it. So here's the order of it. So your big boy number would go in the numerator. So we make it log sub 10, 8, and we would divide by log sub 10, 32. So you take your big number, put it in the numerator, you take your sub number, you put it in the denominator. Now you could just do this in your calculator. So on my calculator, if I do log 8, I don't even hit equals. Then I just hit divided by log 32. Then I hit equals. It'll tell me 0.6, which is correct. Now, on this particular problem, we're going to try what it says here. If possible, choose a base that is a root of both values. So if we were to say, to set up an equation here, and say 32 to the x power equals 8, both of these are 2 to the something power. 32 is 2 to the 5th power. 8 is 2 to the 3rd power. Now here, power to power you multiply, so 2 to the 5x equals 2 to the 3rd. Once you get that common base, we're just going to set up and solve an equation with the exponents. They're both 2's, right? So we can ignore the 2's. So we're just solving the equation 5x equals 3, which we would divide by 5, and we get x equals 3/5. This is the better answer. Now, if you did 3/5 in your calculator, hopefully my spit didn't just show up on the video there. There was a big spittle that shot out. I said, hopefully your calculator. If you do 3/5 in your calculator, it tells you it's 0.6. So it's fine, it comes out the same way. But this is the better way to do it if you can, and you're not always going to be able to do that. So again, if we were doing the change of base formula on B, we would say log of 27 over log of 9. Both of those have a base of 10. Your calculator will handle this. You can just toss it in your calculator. It's log 7 divided by log 9, and you get 1.5. And that's great. We're going to get 1.5 a different way, or 1.5. Because both of these can be written as 3 with an exponent. So our equation would say 9 to the x equals 27. Now 9 is 3 to the 2nd. 27 is 3 to the 3rd. So multiply the exponents. We have 3 to the 2x equals 3 to the 3rd. Ignore our 3's, and we just solve the exponents. 2x equals 3, divided by 2, and you have x equals 3 over 2. And 3 over 2 is 1.5, or 1.5. So you might say like, hey, I like it better changing this. Okay, that's fine. I like it better this way. I think this shows a little more understanding of the concepts, but whatever. So, on a problem like this, if we were to set up an equation 3 to the x equals 7, they don't have a common base that we can use like we did on the first two. So this would be one where we have to change the base. So the log 7 would go to the top, log 3 would go to the denominator, and this one's going to work out to a decimal. Anytime you can't get that common base, you're probably going to get a sloppy decimal. So let's see, log of 7 divided by log of 3. And it's customary to round to the 3rd decimal spot, which is the thousandths. So this, I get 1.77124, blah, 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 blah. So we're going to round it to 1.771. So that's a rounded answer. It's not an exact answer. But hey, that's cool. So on D, so again, if we were to set up an equation, they don't have a common base that we can use here. So we're going to have to do the change of base formula. We're going to have to do log 0.1 divided by log of 9. Now again, you can change the subs to anything. You can make this log sub 5 of 0.1 over log sub 5 of 9, but why would you? Just use the log sub 10, and then your calculator defaults to like log sub 10. So let's try this out. Log 0.1 divided by log of 9. Oh, negative 1.0479, so we'll say 04 8. That's it, man. That's all I got for you today. Those are the properties of exponents with logarithms today.